Hey guys, in today's lesson we are going to look for transformations of square root functions. First thing we want to remember is the equation. So it's y equals a times the square root of x minus h plus k. H is our horizontal shift. That means it moves left and right. When it moves left, it's negative, it's moving towards the negative side, and when it moves right, it moves towards the positive side. One other thing we have to remember about h, though, is that it lies, so we need to move the opposite way. Okay? When we're looking at k is your vertical shift, which is an up-down movement. When it moves up, it's moving positive. When it goes down, that is negative. And then when we're looking at a, if a is positive, it does not reflect, and it will open up. But if a is negative, it will reflect, and it will open down. And then we also have our vertex. Our vertex is always found as hk. But when we're looking at our equation, h, because it is negative, that's why it lies. K is positive, that's why it always tells the truth. So h, you have to remember that it lies, so you do the opposite. All right, so when we're looking at these equations and we're trying to match up which equation goes with which graph, the first thing I'm going to do is I'm going to check A. So if you're looking at our choices right here, you see that A is right here, so it's negative. A here is positive 2, and A here is a positive 1. So right away, if it's negative, that tells us that it reflects and opens down. And the only one that's opening down is this one. These all open up. So without doing very much checking, A has to be this one, number 3. Okay? And then between these two, the easiest way, the second thing we're going to do is we're going to look at the vertex. So the vertex is HK. So if I label these here, this is A, H is over here, which is not existing, and K is here. If A doesn't exist, it's 0. K always tells the truth, so it's -5. So we're going to find the one that is, the vertex is at 0, -5, and it's pretty obvious this one is, because this one, we're moving to the right, so there's no way your x value will be 0. So this one is 0, 1, 2, 3, 4, 5, and we're at B. This one has to be C, but let's just make sure. Let's practice this. Here's A, here's H, here's K. H always lies, so instead of -7, it's a +7, and K tells the truth, it is -8. So if we go to 7, -8, it's going to be, the vertex will be here, so this one is C. So go ahead and pause the video right here, try these 3, and then unpause it when you're done to see how you do. All right, so hopefully you got the first one is B, then A, then C. On this one, you can see these two open down, and there's only one that opens up, and the one that opens up has to be A is positive. These two have B as negative, so that's why they match. The next thing we're going to look at is we're going to practice looking at a graph and listing the transformations, or I'm sorry, at an equation, and we're going to list those transformations. So list the transformations of g of x. And I always like to write a little reminder so that we can see this, the equation. We start with a, x minus h plus k. Little reminders, k moves up and down, h moves left and right, and it lies, so you always have to do the opposite. We also have to remember that a, if it's positive, it does not reflect, but if a is negative, it reflects. All right, so if we have f of x, here's our parent function. So if we start with our parent function and then we have g of x over here, we're going to give directions on how this moved to become this. So looking at this, the first thing I want to do is I want to label, put my a, h, and k above each one. So a would be here, and it's not here, so it's 1. H would be here, and k is always at the end. That is not under the radical sign. So when we tell how it moves, we're going to look at each letter. First, we're going to look at A. Well, since A is positive 1, that means it does not reflect. We're going to now look at H. Since H is not there, it's 0, so there is no horizontal movement. No horizontal . And then the last one we're going to look at is K. K always tells the truth. So if that says -5, K is -5. Negative means you're either going up or down. So you go down 5. Okay? Let's try another one. If we have a cubed root function, it's still going to be treated the same way. There's a cubed root function, and then we'll do g of x is negative times x plus 7 minus 4. So we'll label each one. Here's where A is, here's where H is, here's where K is. And if we look at the movement, the transformation, start with A. A is here, it is negative. Negative means it reflects. H always lies. So since it says it's 7, it's actually -7. And how does H move again? H moves left or right. So if it's negative, that means it's moving to the left. And last one we have is K. K is -4. K always tells the truth, so it stays -4. And negative in this case means moving down. So down 4. All right, so we have one last part to cover. We're going to look at a little more transformations. On this one, we are going to graph this, and then we're going to shift it according to what it says right here. So this says we want to shift, after we graph this, we're going to then shift it down 1 and to the left 2. And then the final thing is we're going to write the equation for g of x, because we have f of x, but we're going to create the equation for g of x. So the first thing we're going to do is start with graphing f of x. So f of x, to graph it, we're going to create a xy table. And since we already know the vertex by looking at the graph, we'll graph the vertex first. Remember, here's A, H would be here, and K is here. H is not there, so it is 0, and K is -6. So that's where our vertex is going to be located. So let's go to 0, 0, -6. To get the next point, since we're working with square roots, we want to use perfect squares. Because if we use perfect squares, it makes the math a lot easier. Like if I put in a 2 here, there's no square root of 2, and we would get a decimal, and that would be really difficult to graph. So we're going to think of, what's the next perfect square? Well, after 0 is 1. 1 is a perfect square. So if I put 1 in here, let's just look at that equation. Square root of 1 minus 6. Square root of 1 is 1 minus 6 gives you -5. So our next point is going to be at 1, -5. So from the origin, we're going to go over 1 and down 1, 2, 3, 4, 5. Okay. And then our next point we're going to put in, if we put a 3 in here, 3 is not a perfect square. We'll get a decimal. So we're going to do 4 would be our next perfect square. If I try this one, let's do this. Square root of 4 minus 6. So square root of 4 is 2 minus 6 is -4. So we have 3 points. We can now graph it. Go to 4, -4. And it looks like it opens up, which A is positive, so it should. So we'll go ahead and graph that. Okay. Now we're going to graph g of x next. And it tells us we're going to move down 1 and to the left 2. And so I'm going to follow those directions for every point. This point here, I'm going to go down 1, to the left 2, 1, 2. So that point just moved here. Do it for all 3 points. This point is going to go down 1, to the left 2. This point is going to go down 1, to the left 2. So this is our new, this is how g of x shifted. So not only do we need to graph g of x, but we also have to write the equation. So g of x, to write the equation, we're going to first write the vertex. This vertex, let's figure out what this vertex is. So we're at -2. We went down 1, 2, 3, 4, 5, 6, 7. So we went down -2, 7. So that's our vertex. So all we have to do to write an equation is we just plug those into the graph. The graph, remember, would be y equals a radical x minus h plus k. So on the vertex, let me rewrite it here so we can see it better. -2, -7. This is h, this is k. H always lies, so instead of it being -2, it's going to become a +2. But let me show you how mathematically, why it works that way. A is going to be 1, so we're not going to have to write that. But when we put in h as -2, there's this negative sign. And when we write the negative sign, we still have to write the -2 plus k plus a -7. And so this hopefully shows you why h always lies and x tells the truth. Because when you put at any number next to a negative, it's going to flip the sign. So 2 negatives make a positive. But when you put any sign next to a positive, it never changes. So that's why we say K always tells the truth, because when we put these signs next to each other, it still stays, just like it says here, a -7. So let's look at that just one more time. We say H always lies, so instead of -2, it should be a +2. And we say K always tells the truth, so -7 stays -7. Mathematically, because there's a negative in this equation, it forces the sign to change. But since there's a positive in this part of the equation, the -7 remains the same. So here is our new equation for g of x. All right, let's go ahead and try another. This time we can see that a is negative. Here's h, and because h is always under the radical sign, and k would be over here. So we're going to start just like we did on the other one. We're going to graph it, and then we're going to go down to and to the left once. So f of x, let's make a table. I always start with the vertex because we can see the vertex in the equation, which is 2, but h always lies, so it's going to be -2. And then the vertex, the k value is going to be 0 because it's not there. So we can graph this point first. -2, 0 is right there. Now this part's a little tricky because we're going to have to guess. We're going to have to kind of guess what numbers could work to go next. If I put 0 here, 0 plus 2 is 2, but we're under a radical sign, and 2 is not a perfect square, so I don't want to use 0. Let's try 1. If I put a 1 here, 1 plus 2 is 3, and 3 is not a perfect square, so we don't want to use 3. But let's try 4. So if I take this, leave the negative sign, replace x with 4 plus 2. 4 plus 2 is 6. That's not a perfect square. We're not going to use 4. 5 plus 2 is 7. Nope. 6 plus 2 is 8. That sounds like it works. So let's do 6 plus 2. Oh wait, 8 is not a perfect square either. So we do not want to use 6 because we're going to get a decimal. So we have to just keep doing some guess and check. 7. 7 plus 2 is 9, which is a perfect square. So if we use 7 plus 2, we get 9. The square root of 9 is 3, and then we still have to bring this negative sign down in front. So when we plugged in 7, we got -3. Let's go ahead and graph that point. Go to 7, go to 3. Okay, I did skip a perfect square that I just noticed, and hopefully maybe you noticed too. 4 is a perfect square, and so if I would have used 2 here, 2 plus 2 makes 4. So I kind of skipped that one, but I can still add it. Let's do that over here. If I put 2 in, replace 2 with x, 2 plus 2 is 4, and the square root of 4 is 2. The sign still comes down in front of it. So when I put 2 in, I got -2. And it doesn't matter that it's out of order. So I'm going to graph this point 2 and 2, -2. 2, -2 goes here. Now if you notice, this point is not looking like it should fit, and that's probably because when I look at that point, I said it should be 7, -3. I went to 7 and I went up 3. It should be going down 3. 7, 1, 2, there's -3. Okay, that looks like it works now. So we're going to connect these points. Our graph goes down because there's that negative sign there. And now I'm going to shift it around and see what it looks like when I shift it. So each point is going to go down 2 and then to the left 1. So I'm going to go down 2 and to the left 1. I'm going to go down 2 to the left 1, down 2 to the left 1. There's where g of x would now be. They should be pretty parallel to each other. And then we're now going to write our equation. So we're going to do it just like we did up here. Let's look at the vertex. The vertex is at 1, 2, 3. So we went to the left 1, 2, 3, and down 2. So the vertex is negative 1, 2, 3, and then down 2. So that's your vertex, which is your HK. So when we write g of x, we're just going to fill those in. Start with a x minus h plus k. I'm going to replace h with negative 3, which we know it turns to a positive 3 because when I put that negative sign next to this one, two negatives become positive. The subtraction sign is part of the problem. And then when I put in the negative 3, that's why h lies, because it flips its sign to become from negative to positive in the equation. K always tells the truth. So k is going to be negative 2. Now we simplify our equation and we get, since we don't have a number for a, it's going to be 1. Two negatives make it positive 3. Just like we knew negative 3 lies, h lied, should be positive 3. And negative 2 is our k value, and when they're next to each other, it becomes negative 2. So here is our equation for g of x. You are now ready to start the homework.